So hi everyone. We're here to present the fertilizer runoff alerting tool, or so we're calling it the FRAT. The team presenting here today consists of data scientist, data analyst, some research technologist, and geospatial specialists from all across the government. So we have ECCC, Agriculture and Agri-Food Canada, Correctional Service Canada, NRCan, and yeah. The problem we would like to tackle is eutrophication, which is essentially high concentrations of nutrients that can cause increased growth of algae and aquatic plants in our natural water systems, which results in decreased levels of dissolved oxygen, which has a negative impact on the water quality. It makes it hard for fish and other aquatic life to exist and ends up choking up our waterways. This is a problem that occurs all across Canada. So here we can see that Canada and Ontario have a Lake Erie action plan to reduce phosphorus in Lake Erie. This is a problem in the Great Lakes, in the St. Lawrence River, and Lake Winnipeg. So it's a problem all across Canada, and it's something that needs to be looked at. So to get to the core issue, the cause of the problem, we did a 5 whys analysis. So we have dead zones in Canada, which is the eutrophication problem. Why? Because of oxygen depletion. Why? Because of algae bloom. Why? Because of excess nutrients. Why? Because of fertilizer runoff. Why? Because of heavy rainfall. Now I want to note, heavy rainfall is not the only cause for fertilizer runoff. Also, the timing of the application of fertilizer is a key challenge that we want to look at here. So our challenge being runoff fertilizer, our solution is a smart alerting tool for farmers so they can time their application, and which hopefully will result in reduced nutrients in our natural water streams, leading to a reduction in eutrophication. Now I'll pass it on to Heather for a quick demo.
So we took a look at some of the applications that are available through like the Apple iOS or Google Store, as well as different weather predictions that are available. And so we're suggesting there's AgriWeather as an application that could be a web page that we have in addition to some of the other Environment and Climate Change Canada pages that are available, could be added to the WeatherCan app that is managed and run by Environment and Climate Change Canada, as well as a subscription service. So I'll just switch over to a website to show you kind of what that demonstration looks like. We're just showing completely fictitious data just to represent what we think the application could present. So we have the option to subscribe, so a user will be able to subscribe to a specific region. And then in the map, the user could either enter in an address or just a town. And we're using a geocoder, we're able to get the coordinates and have the map zoom to that. Right here, we're presenting, depending on the quality of the results of the model that Gherkinwal will talk about in a minute, we might be able to present kind of 1 kilometer square pixels and give a prediction of the probability of runoff over different temporal periods. Maybe it's today or 1 to 3 days, tomorrow, or longer range forecasts as well. And so the map will update dynamically. If the model is a little coarser, we may end up with just kind of predictions potentially at like a watershed or a sub-watershed level. And then we're also looking at some other useful information that could be useful to farmers, maybe precipitation levels, height of the water table. We may connect to some other services that Environment and Climate Change offers, such as the radar precipitation rate or some kind of predictions of humidity or wind. So I will come back to the presentation. Looking around the Government of Canada at who kind of some natural partners would be, Environment and Climate Change Canada and Agriculture and Agri-Food are kind of the key primary stakeholders that we think would have some interest, and we've reached out to some people in these departments. We've spoken to a person at the Natural Research Council who's looking at some water quality sensors, and then the data would need to be stored in a database with some spatial components. So Microsoft could play a role here as well. So I'll hand it back to Gerkenwald to talk about the data sets and the model.
Thanks, Heather. Yeah, so for the data sets, we've looked at three main data sets that are available for us to use. One is the Meteorological Service of Canada's GeoMet data set, which provides public access to the weather, climate, and water data sets. We have DataStream, which is an open access to water quality data across Canada. This was developed by the Gordon Foundation. This is in collaboration with regional and regional monitoring networks, so it includes both governmental and community-based data. And thirdly, we have CanVec, which contains topographic data, and this we're planning on using to get land use and land cover data for the modeling. And this is organized and published by NRCan. One struggle that we had was getting enough water quality data. So one of the other solutions we're looking at is partnering up with the Natural Research Council's National Nanotechnology Research Center. Adam Berggren here has agreed to help us out with a data collection program. His team has biosensors that can detect different nutrients in water. And he has agreed to get one of his co-op students to tune biosensors to detect phosphorus as something that they can have something to do in the meantime, and then we can see how that works out. So we have this great partnership established for a data collection plan. Looking at the data workflows, so our main data sets, which is a weather forecast and the terrain data, is the two data sets on the top left that you see that'll feed into our runoff predictor model. The output from the prediction would go into an alerting subsystem. This will also take in user information to send out the alerts to, which will get sent out and stored in an alert report. Really, to evaluate how well our product is performing, we'll take the water quality observation data and do kind of an evaluation of how well our system is doing, and obviously log all that in a journal for a future analysis. So for the predictive modeling, the back end of the alerting tool is a predictive model. Our current thought is that it'll be a time series model that's capable of predicting future water quality levels. It's going to be trained on weather, land use, and water quality data. Essentially a three-step process: data pre-processing, which will include things like feature selection, feature engineering, cleaning up the data, standardizing. The actual machine learning part of it, the model training. There's two different approaches we can take: a classical machine learning approach, which includes different regression algorithms. We can try linear regression, SVM, decision tree, or we can take a deep learning approach and look at RNNs, recurrent neural networks, including LSTMs. And finally, evaluating the model, we can define some appropriate metrics, such as the mean squared error, or the root mean squared error, or the root average error, and the R2 scores. And now I'll pass it on to Kalina to talk about some challenges.
Thank you, Gerkenwald. So we highlighted some costs and the potential returns this tool will provide here on the screen. A simple scale was used. Low ROI on the bottom here includes effects on Canadian taxpayer dollars. Medium ROI, where infrastructure already exists. Reducing HR and tech costs by using, for example, ECCC's existing weather app. And a high ROI in key public and government interests, including climate change and innovative tech. Our overall initial indication is that the ROI will be high for this solution. The solution will benefit the public in different ways. As a farmer, main benefits will include direct guidance from the federal government on fertilization times to help with scheduling and to reduce greenhouse gas emissions and operating costs. Citizens will then be happy to see they have less water treatment required in their drinking water, with Indigenous and rural citizens especially benefiting with common use of wells. Finally, us in the public service will directly benefit by seeing data strategy roadmap implemented by the Privy Council Office in 2019, being actively supported by our solution. So all of this sounds great, but you're probably wondering how we will do it. Well, as described earlier, we will start with our data collection and modeling, moving on to partnerships, and ending with our web and mobile app development. And so in closing, we wanted to finish with a quote, just stating that some countries are the lungs of the world, and we urge them to take care of their forests. Canada, with 20% of the world's freshwater reserves, is the kidneys of the world, and we don't want to be guilty of putting the planet on dialysis. Every effort to take care of our water is worth far more than the amount of money we invest in it. So we appreciate your time this afternoon and now look forward to any questions you may have. Thank you.
Thanks very much. Okay, great. So open it to questions. Perhaps start with AFC or?
Sure. Bonjour, I'm Elise Lejeune. I'm the Chief Data Officer at Agriculture and Agri-Food Canada. Thank you for the great presentation, and I really appreciate the collaboration between different departments. I agree with you. It's a very top of mind issue. The tool looks interesting. I appreciate that you're leveraging existing resources. I'm a bit curious about who's the audience for your alert? Is it the farmer? Is it like who are the people that are using this great tool? And I think that there's another aspect in your return on investment. I think fertilizer is probably one of the top input costs for any farm in Canada. So I think there is another reason why, if maybe I'm making a leap, you can correct me if I'm wrong, but by choosing the right time to apply, you probably have less to apply, and therefore it's going to cost you less and it's going to be more effective. I see nodding. So 20 years at Agriculture Canada, you pick a thing or two up. So I'm just thinking maybe that's an aspect you want to push as well, right? It's good for the environment, it's good to measuring things, but there is clearly a direct return on investment for the folks that are buying the fertilizer. So those are more comments than questions, I guess, except for the audience one.
Yeah, for sure. So the audience, target audience, or the target end user for us is the farmers. Currently, I think farmers are advised to not apply fertilizer when there's heavy rainfall in the forecast, but this kind of gives them more of a solid foundation to kind of base their judgment off of, rather than just looking at the forecast and making an arbitrary decision. And yeah, like you said, this does help the farmers save a lot of money from not applying fertilizers when it's just going to get washed away. But during the development phase, our focus was the environmental aspect of this. But yes, there is definitely a cost save for the farmers as well.
Thanks. Derek?
Yeah, thanks very much. Fantastic presentation. Derek Dobson from Microsoft. Blown away. That's absolutely brilliant. It was really exciting and fantastic stuff that you're looking at. I think I'm going to riff off those comments because I find it really fascinating. I was taken, as you were describing an approach there, that it was very much kind of, I get the use case, I get the point for farmers, but obviously you're looking at it from the environmental piece and for them to avoid damaging the environment rather than the what's in it for them piece, which I think they're both the same, right, to be honest. But I wondered if there's a slight tack you could take. When I look at the technology uses that are out there today, that are using hyper-localization of AI and data, kind of from IoT sensors in farms, etc., so that you know exactly when to plant crops, when to fertilize them, how to get the maximum yield from their crops. Almost, how do you appeal to them from that perspective? Because that, frankly, hits them in the wallet and is more likely to get them to move to a better activity. So, is there a kind of a way that you can vibe that into your solution, or have you thought of it from that way?
Yeah, no, we haven't. Sorry, go ahead, Heather.
That's a great point. And some of the data sets that we looked at the beginning of this was, the different soil types, the types of crops, the age or when you kind of plant them through the cycle. And so, I think maybe this could be a first kind of proof of concept with kind of the runoff from the fertilizer, and then some other value-added products could go into those more advanced capabilities where we could drill down into those issues a little bit greater.
Yeah, we haven't gone into the modeling part of it yet, but the way the model's set up, we can include as many features as we want. So like Heather said, soil characteristics could be one of them, and whatever the IoT or sensors that farmers are currently using to know when to apply fertilizers, the features that model or that product uses could be implemented into our model to kind of incorporate everything for a more optimal solution.
Yeah, absolutely. And I suppose that's what I was coming to with the what's in it for them bit, because ultimately you can provide something that's really super clever and sits on a government website that nobody checks. Like, how are you going to attract them to want to use this because there's something in it for them? I think that's where we're going. Thank you.
Hi, everybody. I'm Lucille Wagnon. I'm the CIO of Environment and Climate Change. Thank you for this great presentation. Very interesting project. I think I heard WeatherCan, but I was not sure. Can you just confirm from a dissemination perspective if you were going to piggyback on the WeatherCan application, the mobile app? And then the other thing is, one of the questions I had was how far you were from having a model point of view. I think you've not really started from Gurkamal's answer. Have you kind of evaluated like the amount of work required from where you are today to having something implemented? Like how big is this? Like how much work would that represent? And then, like, what kind of dollars do you guys need to actually get to the end? Thank you.
I guess the first part of your question, the WeatherCan app, yeah, that is something that we have considered, and it's something that already exists. So I think implementing it as a part of that would be an easy way to get the product out. Yeah, in terms of the modeling and the time required, it's hard to say, but it like the data sets that we currently have, they're good to kind of come up with a preliminary model, but it's hard to judge how good that model is going to be. If we need to go through the route of actually setting up a data collection program, then that I assume we will need to actually have sensors out in the water streams collecting data for probably a few years before we can actually do any modeling. So from that point of view, then it'll probably be I would say a couple of years before we'll have a model. Yeah, and when it comes to the cost, I'm not too sure about things like that. I don't know if Kalina or Heather, you guys have any judgments.
Yeah, so I dove into the costs a little bit more, and although we weren't able to come up with actual dollar figures, we did have some arbitrary costs and some examples. So technology, we would need a server and a database to host the website and the web app. We would also have some HR costs for hiring maybe 1 or 2 staff to maintain the solution and the database backend things. As well, we would probably need some funding for advertising and marketing the solution to the farmers and our end users.
I would suggest that you partner with Meteorology Service of Canada, which is part of Environment and Climate Change, because this is their bread and butter in terms of developing models and disseminating data to farmers and to all kinds of audience from a meteorology perspective, but also other indicators. Je vais vous laisser de la place pour poser vos questions. Go ahead.
So really, sorry, Wesley Young from Statistics Canada. I forgot last time. It really interesting, and it's got all kinds of stuff going through my mind. And one of the things, a couple things I'm wondering about, is this type of stuff. I think is going to be very, very regional. Okay, soil types. The sort of the geology of the land. Sorry, I'm not an expert, but what happens in the prairies will be much different than what happens in Ontario. We have nothing but rocks, which happens different than PEI, which is all clay type thing, right? So I'm curious: is there enough local level type data to put into your models? Because your model, essentially, you're going to have to model almost by ecoregion, I think. So you need to make sure. You can put the ecoregion as one of the variables in the model, or you can have a separate model for each. I'm just curious whether that data is available. The other thing I'm curious about is if it comes down to a farmer of, following the advice, okay, or potentially losing his crop, I'm trying to figure out what the farmer might do. Okay, so it looks like there's a 50% chance of rain coming up over the next 3 days because we know that weather prediction is like 100% accurate. Okay, so if it comes down to, oh, if I don't put this on now, my window's closed, I'm gonna lose my crop. So I'm wondering how that might play into it as well. And if you don't have an answer to that, that's fine. That's human nature. So if you don't have an answer, just feel free to say I have no idea.
Yeah, for the modeling, we would need to have a separate model trained for every location that we want to have this product for. So the idea would be to identify sensitive areas across Canada, to look at drainage areas that contribute flows to that point of interest, and then kind of monitor the water quality at that point. And then the alert will go out to all the farmers that have farmland within that drainage area. So yeah, so it would require a lot of data all scattered across Canada at different points of interest, and then have it model trained for each of those locations. And yeah, like you said about the farmers, I mean, I think lack of uptake is definitely going to be a challenge. It's this I don't know what the process would be to make this a regulatory thing, but as just an advice or an alerting tool, yeah, it's very possible that farmers will not take it very seriously. But
And just to add on the potential for a loss of crop, I believe that there is insurance for crops, so that could be a help for farmers, just in case the prediction is incorrect in some cases and they do lose crops. As well, it is just a recommendation, just as any other weather forecasting app. So that does come with its cautions and its risks as well, which we will be sure to notify farmers about and any other users when we do launch the product.
So hi, my name is Jason Reed. I'm the Chief Information Officer for Natural Resources Canada. So I think I saw in the presentation you have a team member that was from NRCan that works with the Canada Centre for Mapping and Earth Observation. Is that correct? Great. Okay, because they have, from a mapping perspective, they're doing some incredible work, especially with AI. I see a sort of a cross link with the work that you're doing. Just a couple of comments. The first is in and around engagement of our Indigenous peoples, and so anything that we talk about from an environmental perspective, dealing with lands and watersheds and lakes. If we haven't had those discussions yet, I would consider at least an engagement plan, a stakeholder engagement plan, to make sure that our First Nations are involved and have an ability to contribute. There's a lot of really interesting research on what I'm looking for, traditional environmental practices with some of the great work that we're doing now with satellites. And so sort of the cross-referencing of those two could be have a lot of value in what you're trying to accomplish. So just a point for consideration. From a technology perspective, I mean, there's lots of ways to go about this one. I like Lucy's idea, partnering with ECCC or even AAFC. What I'd hate to see happen is just, one more web server gets brought online for a project that could easily be melded into something that we already have. So just considerations from a technology perspective, but overall great work, and I wish you all the very best of luck.
thank you.
Thank you. Yeah, I hope to see one of the outputs of this would be just a data set. So in the demo it's just a GeoJSON file that's been created that has kind of what that prediction is. So it would be kind of a low level data set that is able to be put into any application. And yeah, certainly using some remote sensing, getting some normalized different vegetation index that we can get weekly and be able to figure out kind of like the moisture in the soil with the rain that has happened, as well as the rain that's predictive, that will help with the prediction of the model. Thank you.
I might have a follow-up if there's a little bit of time. You mentioned something about nanotechnology and a partnership during your presentation. So I'm just curious if you could just expand on this a little bit. And I'm assuming this is bringing some innovative techniques to the project.
Are you the National Research Council partnership?
Yes.
Yeah. So it was actually my old manager who introduced me to Adam from NRC, and he has a team of he has a team of researchers that are tuning biosensors for detecting different pollutants or nutrients in water. And so how the biosensors work is it's a probe that kind of measures the voltage across two probes, I think. And then based on that voltage, they're able to see what the concentration of certain pollutants are in the water. But those biosensors need to be tuned for every specific pollutant or every specific nutrient that we're looking for. So what they're doing now is tuning it and testing it for phosphorus. Because for our product, phosphorus would be the main key indicator, nutrient for eutrophication. So they're going to see how well it does. One issue that was brought up with those biosensors using voltage is that if we see a big spike or big drop in voltage, how do we know it's exactly due to phosphorus and not some other pollutant that's coming in with phosphorus? So those are some of the questions that were raised, but we're going to wait and see what kind of findings they get from their lab experiments.
Thank you.
Great. Okay. Well, thank you very much for your presentation and for your answers to the questions posed today. And with that,